Okay, so this is the first part of the video. We're going to do 3.1 quadratic functions and models. So a quadratic function is a polynomial function of the degree of 2. So the quadratic function is a function of this form. This is very important to know. Then we're going to talk about how we graph a quadratic function using the standard form. So if you notice some things that I've highlighted, I highlighted the fact that we're going to be talking a lot about standard form. You can use standard form and find it by completing the square. Notice that the parabola has the vertex of HK, and if A is greater than 0, it's going to point upwards. If A is less than 0, it's going to point down. So notice here in this area we have a minimum and we also have a maximum, which we'll get into a little later. So the first example, it says for the equation 2x squared plus x minus 6. First, we're going to express the quadratic function in vertex or standard form. We're going to use our calculators to find its vertex and x and y intercepts, and then we're going to lightly sketch the. So first here, I'm going to do part A, which is taking this equation and setting it equal to 0. So I'd get 2x squared plus x minus 6 equals 0. So I want to get into standard form, which means I'm going to have to do completing the square. If we remember, we talked about how we're going to have to divide each part by 2, simply because we don't want our a value to be greater than 1. So I'm going to divide by 2. That gives me x squared plus 1 over 2x minus 3 equals 0. I'm going to kind of put 2 up here in a circle, simply because I'm going to need it later on at the end of the equation. So at this point, I'm going to complete the square. I get x squared plus a half x plus, I'm going to leave a space holder, equals, I'm going to go ahead and move 3 over, and I get 3 plus another space holder. Remember, you can find this portion here, this open portion here, by doing b over 2 squared. That means my b value is a half over 2, this whole entire quantity squared. So I do a lot of keep change flip here. So I get a half times 1 over 2. This entire quantity is squared. Well, a half times a half gives me a fourth squared. A fourth squared gives me 1 over 16. So that means that I get 1 over 16 as my new C value. Go ahead and erase this here. All right, so now I'm going to try to set up this vertex form that I am looking to use. Remember, I need 2 parentheses here equals, and we'll come back to that other side. So I know that this is going to be x, this is going to be x. I'm looking for some sort of fraction that I can multiply the two numbers, being the numerators and the denominators, that will give me 1 over 16. And I come to find out that that value could be positive 1 over 4. So if I multiply 1 times 1, that gives me 1. 4 times 4 gives me 16. Now let's look at the right side. 3 plus 1 over 6. Remember, this is a uncommon factor. Oh, this should be 16, sorry. Looking at this, there's no common factor involved here. So I'm going to have to find a common factor. If you do so, you'll get 49 over 16. At this point, I'm going to go ahead and group these two. So I get x plus a fourth squared equals 49 over 16. Now, in order to get it in standard form, I'm just going to move this to the other side. So I'll get x plus a fourth squared minus 49 over 16 equals 0. Well, it's kind of in standard form already. However, remember at the top here, we circled this 2. It's simply because I have to multiply this entire equation by 2. And if I do so, that gives me 2 times whatever x plus 1 over 4 squared is, minus 49 over 8 equals 0. You're just multiplying 2 times this whole section and then 2 times the 49 over 16, and that just simplifies. Well, this is giving me the standard form, so this answers part A. Part B simply says find its vertex, its x and y intercepts. So for part B, I can find its vertex by looking at H and K. So remember, H and K is its vertex. So my vertex is simply negative 1/4. I have to change its sign, comma, negative 49 over 8. So there's my vertex. As far as my x and y intercepts, we're going to go ahead and go to our calculator. So I'm going to go ahead and plug in my calculator this equation. 2x squared, or let's go ahead and put our vertex point in. So I get 2 parentheses x plus alpha y equals, that gives me my 1 over 4. Close your parentheses and square that, minus alpha y equals, and that gives you 59 over 8. Let's go ahead and graph that. There's the graph. Well, my graph is not necessarily in standard form. So here's the graph. This is how we find the x-intercepts. You're going to go second, trace. You're going to see here it says values and 0. I'm going to scroll down to 0 because that's where I want to know what my x-intercepts are. Notice here how you have ask you for its left bound. You're going to scroll over until you get just above the graph. Enter. Then it's going to ask you for a right bound. You're going to go just below this intercept and press enter. And then you're going to just kind of guess and press enter again. Here's one of my values at -2, 0. So I'm going to go back to the screen. My x-intercepts, at least one of them, is going to be at -2, 0. And then my other intercept is going to look at the other side. So I'm going to do again second trace, looking for the value of 0, scroll all the way over until you get to the left bound. You're going to go just above it, your left bound, or sorry, just below it, your left bound. Enter, go just above that intercept, enter, and then guess. And it tells you that your value is at 1.5, 0. So I have 1.5, 0. That is my x-intercept. Also, we have to find the y-intercept. So with the y-intercept, something new, you're going to go second trace, and then you're going to go to where it says values, which is already highlighted here. Notice how you can push what your x is, enter in your x. Well, we want exactly where x crosses, where x is 0 and y is some value. So I'm going to go ahead and put 0 in and press enter. And that tells me that my y-intercept is at 0, -6. From here, you all can lightly sketch the graph. It does something like, looks something like a parabola. So somewhere down in here does some type of graph like this. Again, this is just a sketch, not exact. So I want you guys to try example 2. See if you get the answers that I've provided here for its maximum point. It's a hint, it's a max and not a min. Take a look at it. Minimum values of a quadratic function. If you let f be a quadratic function with standard forms, f of x equals this equation, the maximum or the minimum value of f occurs at x equals h. So if a is greater than 0, then the minimum value of f, the function, is f of h equals k. If a is less than 0, then it has a maximum value of f of h equals k. Notice here we have a minimum, which we kind of talked about last section, and then there's our maximum point. Okay, so maximum or minimum values of a quadratic function. So the maximum or minimum value of a quadratic function, if we're using it as the ax squared plus bx plus c, it occurs at this entire thing of x equals negative b over 2a. And if a is greater than 0, then it has a minimum value where it's the function of whatever that is gives you your y value, which is your minimum. If a is if a is less than 0, then it has a maximum value where you take your x equals negative b over 2a and plug it in for your function, and that gives you whatever your maximum value is. This is if you were to use the form of a quadratic function. We're going to do some examples here. So it says find the maximum or minimum value of this function. So we have this function f of x equals x squared plus x plus 1. So first I'm going to look for negative b over 2a. So if I plug that in, x equals negative 1 over 2 times 1, which means x is negative a half. Then I'm going to take this value and plug it into my function. So I'd get f of negative 1 over 2 equals negative a half squared plus negative a half plus 1. That gives me a fourth minus a half plus 1, which equals 3 over 4. So that tells me that at f of negative a half, I have either a max or a min at 3/4. And since our a value is greater than 0, we have a minimum value. Okay, so I want you to go ahead and try part B. I'll give you the answer soon. And here's your answer. Okay, so graph and state the characteristics of 2x squared minus 8x plus 3. Well, I went ahead and put it in my graphing calculator, just listing some things of what I know already from previous lessons. So I know that it has a minimum point. Look how low it is. So I know there's a min. My domain is simply all real numbers because it goes on forever and ever, left and right. My range looks like it stops at -5 and includes -5 and goes to infinity. Notice my increasing goes from 2 all the way to infinity. And then I also know that my decreasing occurs from negative infinity all the way to +2. And then everything else I need to find in my calculator. So I'm going to first look for my vertex. Or you can look for your x-intercepts, your y-intercepts. So I'm going to go to second trace, and I'm going to find out exactly where my zeros are for my x-intercepts. So I'm going to go just a little bit below that line here. I'm going to push enter. I'm going to go just above it for the right bound. Push enter. Oh, there's an error there. Might be how we put it in. So let's do that again. Second trace. And then I'm going to do zeros. And I'm going to do the left bound, which is just above it. Enter. Do the right bound, which is just below it. Enter. And then guess. And I get roughly an x-intercept of positive 4, or 0.4, comma, 0. Then I have another one on the other side, and I do second trace, find my 0, scroll all the way over till I get a left bound, enter, just a little bit above it, push enter again, and I find my other x-intercept, which is going to be at 3.6, comma, 0. You can find your y-intercept by doing second trace. You're looking for the value at x equals 0. That gives you to be y is at 3. The vertex can simply be found by doing second trace, and then you can find its minimum value, which is, I'll go ahead and give you Axis of symmetry is simply where x equals 2.